The third part of the lesson, it is a lack of examples of architecture. Intentionally, we focus only on theory and not on the illustration of architecture, building, typology, and so on. The reason is very simple, because the logic of this course, it is not related on illustration of study cases. It is not an endless sequence of architecture and the explanation. In many cases, and this is typical, for example, of some journals and magazines of architecture, the words are simply a comment of the picture. And in terms of critics of architecture, this is wrong. Is not the intention of this course. The intention of this course is to give a precise reason, is to give a precise logic about how one building, why one architecture, it was generated according with that specific logic. Critics of architecture, we remark once again, it doesn't mean criticize, it doesn't mean complain or argumentation against or in favor of a certain author. Critics of architecture, it is a logic and scientific discussion about a certain kind of building, certain kind of poetics of authors, architect, eventually artist and painter and sculptor, and we must try to find the solution, the reason why certain kind of work are created according with some specific logic. This is why the third part of this second class is mostly dedicated to theory, and why we decide to illustrate the theory of the postmodernism and deconstruction. In short, the post-structuralist perspective. Because on the contrary of the modernism, the post-structuralist theory, the postmodernist or the constructivist theory, is extremely deep, is extremely complicated. And it is basically impossible to fully understand what is the logic of a certain kind of building, Michael Graves or Frank Gehry, it doesn't matter, without that precise understanding on the theory on the back. We could love or hate a certain kind of author. We can get crazy for the irony of Michael Graves in his creation, or we simply can't understand what is the logic beside the strange form of Frank Gehry. So we would like or dislike a certain kind of building, but important is to understand. In all the previous class, we have seen a lot of examples. Some buildings are brutalist, something like the architecture of Kenzo Tange, or modernist, or purist, or cubist, or organicist, like Frank Lloyd Wright, or Le Corbusier, or Gropius, and whatever. But the most important point, the most important effort of this course is try to understand the reason, the logic that generate building. That is a very important statement. Now, if you want go deeply inside the understanding of the post-structuralist philosophy, we need to take back some of the key points of the previous class. We said that in the structuralist philosophy, in the structuralist methodology, the main concern of the philosopher, sociologist, but also architect, is to find a sort of superstructures, or better, an hidden structures of the universe. These hidden structures, it's a sort of logic which is beside, which is invisible, but still existing in terms of logic of how the things it works somehow. What we want to express even more deeply is this: the behavior of the human being, the social structures, the logic of the family tree, how a village or a city it is organized, somehow follow a certain kind of structures. These structures are not visible, but it exists. Is it an invention of the modern time? It is an invention of the structuralism? Not at all. It is possible to demonstrate that this form of logic, this form of structures, it is quite old. and it come back to Porphyrius, so it's really old logic. And then it was one of the key methodology, one of the key process of thinking of the scholasticism during the Middle Age. The structuralist philosophy, the structuralist method, take back this form of trees, structures, of hidden structures of the things. It is totally the same? No, of course not. It is much more advanced in terms of structuralist methodology compared with the scholasticism. Actually, the scholasticism is a very complicated and very complex and very complete system of investigation. But the structuralist was a very powerful system to try to understand how the things works. There is always a logic behind the situations. This structuralism, it can be useful for human being, but also for animal. And even today, in the age of the post-structuralism, this methodology, it is still very useful. Maybe there is something better, maybe there is something much more powerful, and we will investigate in the following class, but the structuralist system is quite important even today. It is useful for simple situations. We will take back this problem in the future. If it is clear the structuralist process find as structures of everything, include human behavior, and then consequentially use these structures for the architecture, in the post-structuralist philosophy, this case collapse. Or better, it is denied by a certain form of speculation, which it doesn't come only on the sociology, but it is also, it comes also from science, mathematics, formal logic, and here the case becomes even more complicated than before. But let's try to understand what is the situation now. It's clear that the structures are very useful to understand simple situation, right? For example, if you think about the common family in many society of the world, there are parents, grandparents, child, and so on. Definitely there are thousands of variation. Definitely there is 1,000 of modification of these simple structures, but it exists. The same logic, it was used for every form of social organization. And then finally, the structuralist process tried to discuss what is the best organization for the apartment, city, house, shopping mall, and whatever. But the post-structuralist approach said the situation is not so simple. There are a lot of contradictions that could be invalidate these general rules, or more precisely, the structuralist approach, yes, could find a certain kind of structures which is generally speaking valid, but it doesn't mean that this rule is universal. In fact, the structuralist philosophy can be considered probably the last universal philosophy, the last strong philosophy, the last strong thought. For strong thought, we intend a philosophy which have the ambition, which has the goal to describe the rule of the universe in terms of general approach. They are still thinking that there is one general rule, one general methodology which is able to describe everything. Now, after the structuralist philosophy, this wish, this hope simply collapse. There are a lot of, we can say, there are a lot of situations where these kind of general rules cannot apply anymore at all. In my personal investigation, I find a very interesting case, which is a very early demonstration that the structuralist philosophy, or better, every form of universal philosophy, it cannot be applied anymore. It is one of my beloved scientists in my research, which is Kurt Gödel, one of the most brilliant logicians in the whole history, a very peculiar personality and a very good friend of Albert Einstein, who moved to Princeton during the World War period. He was a brilliant young mathematician. His PhD dissertation was a 23 page of discussion, formal logic, which basically changed the history of the mathematics and the logic. The first and second theorem of Gödel is extremely difficult and extremely technical, and for reason of time, we are not going to describe, but I warmly recommend all of you to investigate the personality and the work of Kurt Gödel. In a very short sentence, and make it very simple, what it is extremely complex, we can assert that the logic, the meaning of the work of Kurt Gödel can be condensated in this concept. Every formal logic cannot be proved with the inner element of the system itself. This criticism, it's not a criticism, this is a conclusion, we can say. It was specifically referred to the mathematics. And in a very simple way, the meaning is, in the mathematics, which is a formal system, there is no evidence, there is no way to prove that the system itself, the mathematics, can be proved being correct or wrong. So it's a sort of undetermined system. In this case, it means we assume, since the beginning of the history, that the mathematics is completely truth. It describes situation, theorem, it's a language which is behind any doubt. Mathematics is not an opinion. This is a very old sentence and all the students heard from their professor. Mathematics is not an opinion. What Kurt Gödel described in his theorem is something extremely complicated, because he said, yes, but there is no way to prove that any formal system, include mathematics, but include language, include everything, include structures, include everything that you can imagine, there is no way to prove that this system is correct or incorrect, or better, it is coherent or not coherent. This is the key point. And then, this is simply a slap in the face of the logic of the human being. In fact, the great mathematician Hilbert, one of the giants of the mathematics in all the history, become very angry after reading this kind of dissertation. Say, who is this young boy who assumed to destroy all the history of mathematics? But actually, Kurt Gödel was correct that that theorem was proved and everyone accepted. Does it mean that this is the end of mathematics? Does it mean that this is the end of every formal structures? No, it is not. It is simply something a little bit thrilling, we can say. There is nothing really sure or better. There is nothing universal. The mathematics, it works. The mathematics has his own system. Certain situation can be extremely coherent and proved, but there is no ultimate way to assert that the mathematics is universally correct. The discussion is very complex. I make it very simple. There are thousands of possible discussion on this topic, but I won't make it very simple. This is a very important statement from Kurt Gödel. Then there are other very important discovery. For example, in physics, Werner Heisenberg, it is another very important and basically one of the key personality in the physics of the 20th century. Is the youngest Nobel Prize in all the history, a first-class genius. And also in his principle of indeterminatus, sorry for my bad pronunciation, but in his principle, very famous principle, he asserts that it is not possible to describe the position and speed of one particle at the same time. What does it mean in a very simple way? It means that it is impossible to know every information of the subatomic particle in a complete way. In short, there is always a certain kind of uncertain information or incomplete information in the description of the reality. And then the question, yes, but it's true that we cannot understand, because this principle is proved by physics, it is true that we cannot understand the position and speed of a certain kind of particle. It is true that everything is probabilistic. But then why the universe exists? This is very difficult to understand. According with Heisenberg, the reality cannot be described in terms of certain things. It is not the classic mechanic of Newton. The classic mechanic of Newton said, if I know all the parameters, all the elements at the beginning of a certain situation, I can predict what happened at the end of a certain dynamic. But in the case of the quantum mechanics, for example, in the case of Heisenberg, this is basically impossible, and not impossible because we don't have the instrument, we don't have the intelligence, we don't have the mathematics to describe this situation. It is impossible for the inherent nature of the matter, for the inherent nature of the reality. Finish. That's it. There is no any other way to solve the problem. We lost all the possibility, we give up science, we come back to the tree, we come back to become a farmer. No, not at all. Because we have Gauss. Gauss, it is one of the key personality in mathematics in all history. He elaborated the probability theory. According with theory of probability, there are not ultimate result, but there are possibility, probability. A certain kind of event, it is not simply yes or no. It happened or it doesn't happen. So in this case, one event, a certain kind of event in the classic mechanic, it could happen or it could not happen. But what Gauss said is something extremely tricky. A certain situation could happen according with a certain percentage. Everything is according with a certain kind of probability. The universe, it is not a certain things, but it is based on probability. That's it. Probability is everywhere. There is no yes or no. Everything is based on probability. But the probability is a tricky stuff, because probability means that a certain event, it may be happen, but it may be not. This has a very strong implication. The implication is that the reality, it is not based on certainty, but it is based on uncertain stuff. Nothing is completely correct. And then there is other key personality in physics, like Ilya Prigogine. Also, Ilya Prigogine discussed a very complicated issue, which we are not going to discuss now, which is the dissipative system. And this is another heat, very strong heat, against the certain, against the one true and universal reality. Now, suddenly appear Jacques Derrida. Jacques Terrida was not a physicist, he didn't study chemistry and no mathematics, but it is a very talented philosopher. And he became one of the most important philosophers at his time because he created a system of thought based exactly on the uncertain process. What he said, in short, we already mentioned in the first section of the second class. He asserts that there is no more universal philosophy. There is no more metaphysics. There is no more universal truth. But everything is an interpretation of the reality. And then interpretation of interpretation. And then interpretation of interpretation of interpretation in an endless form of interpretation. For example, one of his famous books, very difficult to read, is the interpretation of the interpretation of Freud on one novel of Edgar Allan Poe. At reverse, Edgar Allan Poe wrote a novel. Freud interpreted this novel, and Derrida interpreted the interpretation of Freud. And then someone else could interpret the interpretation of Derrida, and so on. Is there any truth? The source, even the source, it is not the truth anymore, because the source, it is only a source, but the reason of, and the meaning of that initial novel, it is still unpredictable, because the real meaning could be under discussion, under interpretation, basically forever. And then, if even the source doesn't have any meaning, where is the truth? That is the point. There is no truth anymore. This is the point of the deconstructive philosophy. There are a lot of very interesting books. Some is very difficult, some is very readable, but the complication of the deconstructive philosophy is very, very high. If we want to make a difficult stuff into simple sentence, we can say that the deconstruction asserts that there is no ultimate truth, but everything is made by fragment. And what is the architecture of Frank Gehry, or the architecture of Kopp Himmelblau, or the architecture of Libeskind, but also the architecture of Michael Graves, of Robert Venturi, and the architecture of Philip Johnson? Fragments, quotation. Yes, because if the reality, if the interpretation is on a certain kind of text, literary text or architecture text, it doesn't matter, it's completely the same, then the problem is we are in front of a fragment of reality, because there is no more one universal reality, but many reality under interpretation, and every interpretation can be correct. Of course, in a certain kind of logic process of thought. But then again, who decide what is logic and what is not logic? Because if I have to interpret a certain kind of situation, an artwork, for example, a painter, the losses of the universal truth definitely assert that every interpretation is correct. And of course, this is a contradiction, because there are coherent interpretation and insane interpretation. Something like the conspiracy theory. The conspiracy theory, it is simply an insane, a paranoid vision of the reality made by insane people, impossible to verify. But the point is that the deconstruction philosophy asserts exactly this. In theory, also the conspiracy theory, or the illogic assertion, or the logic assertion, everything is under interpretation. That is a very important statement from the deconstructivist philosophy. I'm sure this idea is quite irritating, because everything is possible, so there is no universal truth. Everything is unpredictable, so there is no true, no wrong, and so on. Yes, and that it is the crisis. It is the crisis of the modernist, and is the crisis of the Western culture. This is why it is called crisis. But Bruno Zevi once asserted a very beautiful sentence, and in my opinion is very remarkable. What is the modernity? And the answer was, the modernity is what makes the crisis a value. This is a very intelligent sentence, because in all the modernity, and even more in the post-modernity, the crisis become a value. The monster become a central investigation of the reality, and not simply a collateral element. There is one important assertion to add. It is very famous nowadays, the geometry named Fractal Geometry, by one of the greatest mathematicians of all the time, Benoit Mandelbrot. This is very current with our discussion. What the mathematics of fractals assert? Mathematical fractals assert that many things, but a very important statement is that if in the past the geometry, the mathematics, the classic geometry, the classic mathematics study the regular object, sphere, cube, and so on, in the modern time, and in this case for modern time, I won't mention the mathematics of 18th century, 19th and 20th century. In the last 250 years, the mathematics and geometry doesn't concern anymore the regular solid, the Platonic solid, the Euclidean geometry. But there are a very strong study, very interesting speculation about the non-Euclidean geometry with the irregular forms. For example, one of the most important theorem that everyone study in the elementary school is the sum of the angles of a triangle, it is always 180 degrees. Finish. That is the statement. And then that is the rule. But then suddenly, two mathematicians, very important mathematicians, Bolyai and Lobachevsky, find that this is not correct. For example, there are a sort of geometry, the curved geometry, where this rule is incorrect. For example, if you have a plane surface, your table, definitely, in this case, the sum of the angles of a triangle, it is always 180 degrees. But what happens if you sketch a triangle on a ball, on a sphere, or into a very crazy curved surface? The angles are not anymore 180 degrees on that triangle. And then everything collapsed again. It was discovered a much bigger form of geometry, which is called non-Euclidean geometry, which opened a very beautiful and innovative speculation. So we can say that the regular solid, the regular geometry, the order, the universal philosophy, it is just one particular case of a much larger situation. Something like the classic mechanics of Newton is a specific case of a much larger situation discovered by the quantum mechanics and the theory of relativity of Einstein. Like the non-Euclidean geometry is a much larger environment compared with the Euclidean geometry. So the Euclidean geometry is just a particular case, a specific case of a much larger theory. Well, coming back to the theory of Mandelbrot, the fractal geometry, we can say that the fractal geometry is exactly this case. The fractal geometry which describe strange forms, irregular forms. Now, the mathematics of Mandelbrot is very beautiful, very interesting. You can find a lot of beautiful video in YouTube or a fantastic book. I'm not going to describe all the theory of Mandelbrot because it's too complicated and too wide, too big. But on this point, I want to take a few elements. Mandelbrot asserts that the fractal geometry studied he called ironically monster of the nature. For example, if you look the trees, they are not regular. Cannot be assumed like a cone or like regular geometry, but they are a sort of variation of that kind of regular geometry. So if in the past centuries, architects, mathematicians, painter, artists in general, philosopher, they are trying to find a rule, universal rule in this world, regularity, order, and they assume that it exists a certain kind of order. In the modern time, this order collapses because it appears something bigger. So the order is a specific case of a much larger environment. In the future, I hope, it will be another great genius which could extend in a much larger meaning what Mandelbrot already enlarged. Now, we are in front of at least 4 key theories which radically change the history of the human thinking. Non-Euclidean geometry, the theory of relativity, theorem of Kurt Gödel, Heisenberg principle, Mandelbrot, the construction, already 5 or 6. All these kind of theory are collected together, and what appear is the universe doesn't work according with any universal rule, but there are based on irregularity, probability, and everything is a much bigger, much more scary because there is no certain things, but also much more challenging. It's something like in the past you always live inside one room, everything seems clear, then suddenly someone opens the door of your room and then you find the world outside. It is much scary, but much more thrilling and intriguing because you can find a lot of new stuff. And this is what happened in the science and in the philosophy of the last 30 or 40 years. The world become much more bigger. So we have a lot of work to do in the investigation on the nature. This is theory. This is the theory. And then how can we we can use this theory in the architecture? Well, we know very well, because we already mentioned many times in this class, but also in our script, that the architecture, it is always an interpretation of the reality. Interpretation of the reality, it means the architect are a sort of sensor of the time, because they react to the information of their time and generate work which express the society. If we check the work of postmodernists investigated in the previous part of our class, what we find? The postmodernists assert that the history, it is not a heavy weight on our shoulder. It is not something that we have to obey. We have to respect, because that it is the universal truth. The theory of Vitruvius, or the classic order, or the great example of Michelangelo, Raffaello, Andrea Palladio, or whenever, that lesson are in the past, and the past is the past. We cannot take back, because the society of today is different. So we have to be a little bit ironic with the past. They use the past, the postmodernist architect use the past with a certain kind of, as a joke. Again, the past, it is only a quotation. But remember that every time you have a quotation, you extract the original meaning of one text and you paste into another context, so the meaning change. If, for example, I quote Shakespeare in this moment, any sentence, any beautiful sentence of the great works of Shakespeare, in the original play, it has a very specific meaning. But if I quote in another context, the meaning could be slightly changed. Every quotation generate another context and consequentially another meaning. This is why in the postmodernist architecture, when the architect quote, or better, use decoration or an element from the past, they give a new meaning of that quotation. They give a new interpretation. And this one is most of the time extremely ironic. For example, in the classic architecture, there is one figure named Omerone, which is a sort of giant which sustain with their shoulder a balcony, a column, a beam. It is a classic. It is a classic figures in the Renaissance architecture, for example, but also in the Baroque architecture. Michael Graves used exactly the same figures. He used that kind of figures. But if in the past the Omerone was a giant, which his immense body sustained a beam or a balcony, thanks of his great power, Michael Graves used the seven dwarfs of Disney in the famous cartoon Snow White. Well, that is a very interesting irony, because he used classic figures, some human body, human or fictional character to sustain the being, but if in the past they are giant with the muscles and strong body, in this case they are dwarf, and a Disney dwarf, which is a fictional character and very ironically used. When, for example, Venturi categorized all the classic elements and redesigned capitals, columns, and other classic elements in a completely different language, that it is also ironic. So, what is the meaning of all this discussion? The discussion is the history. It is simply a can where we can take what we want and use how we want. There is no more coordinate language, but everything is based on quotation. And then, at that time, start a very strong and sharp discussion, debate, in between the deconstructivist and the postmodernist. The deconstructivist seems to be the opposite, because they use quite a dramatic form, very deconstructive. It means the architecture appear as destruction. It seems that someone take a normal building and with a huge hammer break it. But again, in the deep meaning, we are still in front of the use of fragments. In one case, it is used ironically and probably in a very trivial and sometimes arguable taste. And the deconstruction used in a much more dramatic way. But the deconstruction still use fragment. The deconstruction still use a sort of fragment, not anymore from the classic order, but fragment from the modernist. If you check, for example, the architecture of Günter Dominic, the Austrian master, in the project of the Zentralsparkasse in Favoritenstrasse in Vienna, in that case, he take a very normal international style building and deform, destroyed, the facade become curved. And what happened, for example, in the work of Koppel-Blau, another Austrian very famous group of architects? It's very remarkable, one project made by them. It is a project of urban planning. On the opposite of the architecture of modernist, which is based on very rigid and very solid theory, and on the opposite of the structuralist, which investigate the reality in a very structured way. They have intention to create superstructures, very rigid but very universal. In the case of Koppel-Blau, the design was made throwing object on the city map randomly. They take stuff, throw it, and then freeze that kind of random layout, and from that kind of randomness, they generate the urban planning. It is extremely unconventional. It is unique in the history. If in the past there is always a sort of order, or a sort of method, or a very strict process of creation in architecture, in this case, Koppel-Blau or Günter Dominic, they destroy every form of method. If the postmodernist generate a sort of ironic play with the history, the deconstruction intentionally destroyed, brutalized the history of the modernity to create unconventional space. One very interesting element of the deconstruction, and here there lie my personal favor on this trend, is the complexity of the space. Architecture can be described as space and light. This is the two essential elements of the architecture. And the space in the constructivist architecture is extremely challenging. It's very interesting, very dynamic, very dramatic. It is my personal taste, and I don't want to impose anything to anyone, but I must express my feeling. So, on this point, we can say that deconstruction and postmodernist are at the same time very coherent, very similar in terms of the deconstructivist philosophy, fragments, irony, assertion that there is no more universal rule, but at the same time they are opposite. One is very ironic, easygoing, playful, another is very violent, strong, based on destruction of the form. I think it was very important to remark the differences and the difference and the similarities in between postmodernist and deconstruction architecture. In the next section of our class, we will discuss some great authors on the deconstructivist architecture.